What's up, Algebra 1? Sorry, I started the video and I had a fruit snack in my mouth. I had to swallow. Okay, so lesson 2, we did this in class this morning. We're starting to look for these different types of relationships other than linear and exponential. And so we started looking at these patterns of these dots and blocks as they grow. And what we found helpful today when we were investigating them, so we're looking at these 3 different patterns, and we're talking about the one that's going to show a quadratic, our new relationship we're studying. And so, if we can look at these patterns and maybe recognize them as old ones that we're familiar with, maybe we can, by process of elimination, figure out which one's quadratic here. So, what I like to do in these patterns, since we're just looking at dot growth, is over top of them put how many dots are there. So, like in step 0 and the first pattern, there's no dots, so 0. And this one has 2 dots, and then there's 4 dots, and then there's 6 dots, right? So the first pattern is pretty basic. We've seen this type of growth before. If we were to continue, we'd tack on another 2 dots, and we'd have step 4. Step 4 would have, 8 dots on it, right? And so every time that we go to the next step, we have a change of increasing by 2. And every time that is just tacking on 2 more dots, right? And that type of relationship, we've come to realize that that is just a linear relationship because we're increasing by the same amount every time. So pattern A is just your straight up run of the mill linear relationship that we've seen for a long time. In fact, this one is just a proportional linear relationship because you're starting at 0 and you're going up by 2 every time. So there's not even like a plus or anything that's involved with it like we saw in class today. But if you look at the next one, all right, this one's a little bit harder to distinguish because you start with 1 and then you go up to 2 dots and then you got 4, 5, and then you got 3 by 3, which there's 9 dots in this. Add that extra 1, there's 10. And so if I was to do this again, my guess is that step 4, it looks like they're just kind of growing um, this square and tacking one onto it every time. So think of this as like this is the root of where I'm starting, and then I went up to a square that was 2 by 2, and then I went up to a square that was 3 by 3. And so my next one would be a 4 by 4 square with a little dot attached to it, like all of these were. So my next step would be 1, 2, 3, 4 by 1, 2, 3, 4, and then fill all the dots in for that. Like I can anticipate that's what the next step's going to be, which would just be a 4 by 4, 16 dots plus 1. I'd have 16 in that progression. And so my growth pattern here is 1, 2, 5, 10, 16. Well, they're clearly not adding the same thing every time. Add 1 doesn't work every time. They're not multiplying by the same thing like we would see in an exponential function. Times 2 doesn't work there. Times 2 does work there, but it doesn't work there. So it works sometimes, but it doesn't. So it's not exponential. So this one is probably where I'm leaning to be quadratic, but we'll come back to that. Let's look at the last one. Okay, the last one down here has 1, and then it's got 3, and then it's got a 3 by 3, which is 9. And then if you kind of break this down into 3 by 3s, it's got 3 of them, right? And 9 times 3 is 27. So like if I did another step of this, I'm not going to draw it, but it appears that this one has a relationship of they're just multiplying by the same factor to get the next one. And this one's going to start growing very quickly because 27 times 3 is going to give you a very large number, right? 60 and 21. So you're going to get 81 here whenever you multiply for step 4. And that would continue to grow by a factor of 3 every time. And that we've come to know is an exponential type of relationship. But they want us to pick the one that's quadratic. So by process of elimination, this is the one that turns out to be quadratic. Miss Mullins is going to the ISD room. I hope she's not in trouble. But quadratic is the type of relationship that we see here. And what we talked about in class today, something that makes a relationship quadratic is you're going to see this relationship where there's a number in your relationship that's getting multiplied by itself. There's like a squaring aspect to it. You kind of visually see it 1 by 1, 2 by 2, 3 by 3, 4 by 4 squares as they grow here from part to part. But there might also be some addition and subtraction involved. But generally, what you're going to see with the quadratic is you're going to see a growth of a number getting multiplied by itself, right? In this case, the number, 0 times 0 is not all that's happening. They're doing 0 times 0 and then they're adding 1, right? And then they're doing 1 times 1 and getting 1 and they're adding 1. And then they're doing 2 by 2, which is 4, and they're adding 1. They're doing 3 by 3, getting 9, and they're adding 1 to get 10. They're doing 4 by 4 to get 16 and adding 1. Sorry, that was supposed to be 17 when I wrote it down wrong earlier. So this growth pattern right here that we're seeing is squaring a number as a result to get the output and then adding 1 for our particular one. But what makes it quadratic is this squaring action that we're going to see pop up in our functions as we continue to look deeper and deeper into this. So which pattern shows a quadratic relationship? Well, it would be pattern B. Pattern B, because the step number involves taking a square. So we have a n to the second power or x to the second power. We're taking a square. I'm sorry, my handwriting is really bad there, but hopefully you can listen to it and get what I'm saying there. But the step number involves taking a square or multiplying a number by itself. Later, guys.